Hello, everybody. Today, I'd like to talk to you about maximizing the revenue. Before one can maximize the revenue, you have to really come up with a revenue equation. The good news is we've been studying revenue for a while now, and we know revenue is price times quantity. So, if we can come up with a price and quantity equation, we'll find the revenue equation. So let's talk about the given information in this TV company. It has a base number of customers, so that's quantity. Quantity in this case is customers. So there's 4,000 customers to start with, or currently, and they're currently paying $130 a month. That's why I'm putting those both in as base numbers, flat numbers. Now this says for every dollar reduction in price, they will attract 50 new customers. Remember what X is in this question. It says it right up above. X represents the amount of reduction in price in dollars. So if we have a $1 reduction and we do it 4 times, that would be a $4 reduction. And that $4 reduction, I'd want to put it right there, a $4 reduction. If we took off 5 reductions, that'd be a $5 reduction. I'd want to take off $5 here. So what I'm looking at is I want a minus because I am reducing, and I want a 1x based on how many reductions I take. Let's think about that again. If there are a $10 reduction, that would be 10 times a dollar reduction, so it'd be $10 off, so it'd be down to $120 per customer. If we did a $20 reduction, it would be 20 times dollar, so it'd be down to $110 a customer. So that minus makes sense because we're doing a reduction. If this was an increase in price, I'd do a positive. But because this is a reduction in price, I'm doing a negative. Got to be careful of your words here. Now, we're attracting customers. Since we're attracting customers, I know I'm going to be adding on customers. How many? Well, it depends on how much we reduce by. It says for every reduction, we attract 50 new customers. So I'm going to write that, you betcha, as 50x. And so this is how I arrive at my equation. I have my base information, 4,000 and 130. That's where they go, base information. Remember, price goes with price, quantity with quantity. These two pieces are all about how the customers react to price increases. The amount of reduction says for every reduction, we go down that amount. That is, for each dollar we reduce, we go down that much. So if you have a $10 off, 10 times 1, because that's 10 reductions, that's how I'm counting this. X is the number of reductions. So X is 10 reductions. That'd be a $10 reduction. We'd be down to 120. But if X is the number of reductions, then we know per each reduction we earn 50 new customers. So a 10 reduction means we get 500 customers, and we're at 4,500 in customers, and then we can multiply to get revenue. So this is my revenue equation that I would put in that box where it says revenue. Now, where are they getting this? Well, that's because, my friends, they're doing good old algebra. To finish this question off, you have to do good old algebra. The revenue function, well, you're looking at a FOIL here, right? You're looking at 4,000 times 130 when you do the FOIL, and that's 52,000. Or I should be very careful with my numbers, 520,000, so I don't make mistakes for you guys. I'll write a little bigger. And then I do my inners and outers. Think about your inners and outers. My inners is negative 4,000. My outers is 130 times 50. 130 times 50 minus 4,000, you betcha, is a positive 2,500 x. And of course, when you do the last terms, negative 1x times 50x. All right, again, I'm foiling out here. Negative 1x times 50x is a negative 50x squared. So there's my equation that is just like theirs for revenue. My revenue equation is 528,000 plus 2,500x minus 50x squared. From here, now it's just a matter of the typical question they ask is find the maximum revenue. To do that, to find any maximum or minimum, you need the derivative. The good news is we're skilled at the derivative here. The derivative of 520,000, I don't care. It's a constant. It's zero. The derivative of 2500x is 2500. And the derivative of negative 50x squared, bring the 2 down, subtract 1 from the exponent, gives us negative 100x. To continue on, to find the maximum, we set this, r prime, equal to 0. And so when you do that in this question, when you set that equal to 0, the 2500 minus 100x, you get what they, well, first of all, they do the derivative, good check, and then they go straight to the revenue. First things first, we got to find the number of units, all right? We have to find the number of units. And in fact, I'm going to maximize this screen now so I get more screen. So we have to solve this, right? We have to solve this expression equal to 0. And so 2500 minus 100x is x is 25. Now, as good students, we do not know if that's a max or min without the first derivative check. We should be building a chart. We pick a number before 25, like 20, plug it into the derivative. That's clearly positive. Plug a number after 25, like 30, plug it in, and you'll see it's clearly negative. And since you go from a positive to a negative, that guarantees that that's a maximum. And since this is a maximum, we know we have our answer. You should always do this check because when you take the derivative equal to 0, you're not guaranteed a max or min, you're guaranteed a critical point. To ensure that critical point is a max or min, you should do the first derivative check just to guarantee it. So we now know it definitely is a maximum, because if you're going from increasing to decreasing, it has to be a maximum. That's units, remember. This x is units. The question says maximum revenue. So we need to plug this back in, you're right, to the revenue function. We need to go back to the original revenue function, and that'll be our official answer. The revenue of 25 units. So if we go back to our original equation, right, a 25 unit decrease, which means a 50 times 25 person increase, how much revenue do you make? So you plug 25 into both, and you'd get the answer they're looking for. Thank you. I hope you enjoyed this video.